a couple slides here. Just as a review, we just talked a little bit about the early pioneers and the frequency. That's kind of the ideal frequency, if you will, for cellular communications. And we said it's in this range here, roughly 600 megahertz to 1900 megahertz. That's roughly where you'll see most cellular communications. Some of the 5G frequencies are up here in the extra high frequency, but primarily you're talking in this range in the radio waves. We talked a little bit about the properties and look at the early mobile telephony. And then the next thing is the need to increase capacity. Now you're talking about into the 1970s when there was a general need that you needed more capacity than just a few channels. So there's really only three ways to increase capacity. One, you can get more frequency. You'd have to go to your national whatever agency allocates that and you get more frequency. But again, that frequency range, that ultra high frequency, is very desirable. There's not any free or leftover frequency in that range. You can choose the way you modulate the signal on the air, and that was increasingly done in different generations. Or this was kind of the key, at least initially. The key was to radiate less power and reuse those same frequencies at some distance away. That was really the capacity breakthrough, was to divide your total channels into some type of cellular arrangement. So if we look at this here, you have what's known as a 7-cell reuse pattern. That was very common, at least early on, where you would take roughly, and again, it's not going to be totally like this because it's going to depend on different other factors. But if you took your total number of channels that you had, duplex channels back and forth, since you need to talk both ways, and you roughly took 1/7 of them and radiated them in that cell, and 1/7 in that cell, and 1/7 in that cell, and so on this 7-cell pattern, you could duplicate whatever frequency is in a cell at some distance away, as long as you did not radiate too much power, as long as you didn't overpower that. So in other words, the frequencies that were assigned to this cell could be reused here, as long as you didn't blast out the frequency here. You could reuse those same frequencies. And that's the entire concept of cellular. So when you look at cells, there's some concepts. One of them is the cells themselves. The size of them. Now, again, it's shown as a kind of a neat hexagon figure. Now, we know radio waves don't follow hexagon figures. They do, but this is a convenient way to draw the cells. And then it becomes the amount of power that you emit out will determine the size of the cell. So theoretically, you could continue to reduce the power that you're transmitting out, and the cells would then shrink. But like we said the other day, there is a practical limitation. You can't have someone going on a major motorway 80, 100 kilometers per hour and have cells that are just several meters in diameter. There is a practical limitation. So that all gets with frequency reuse. How often do you reuse the frequency? And that's going to be determined by the size of the cell. There's also the handover. When you go from one cell to another cell, you need to be handed over. You're assigned a different frequency. You're assigned a different channel to talk on. And that's going to stay if you stay within the system. But let's say you're in this cell down here, and the very next cell, just pretend there's a cell there, is controlled by a different central switch. Well, now you've got to set up a voice path between those switches. So if, let's say, this cell here controls this range of cells, but this one is controlled by what's known as a mobile switching center. Now you're handed off from here to here, and you go to a different switch altogether. Not only a different cell, but a different switch. That's inter-system handover. So those are the four kind of properties, if you will, or concepts of cellular. So the cells can range in different sizes. You might have a macro cell, which is very large geographic area. So you're emitting quite a bit more power than on a macro cell. And this would be maybe out in the countryside. This would be maybe by major motorways where cars are going along at a relatively large relatively fast speed. You can also have microcells, which can cover areas less than maybe 1.5 or 1.5 kilometers. Again, that's going to be in smaller areas, maybe not as much fast traffic. Picocells, greater capacity and coverage areas, supports up to 100 users in ranges of less than 230 meters. Well, now you're getting into maybe walkways or pedestrian malls or things like that. And then femtocells. So this is just user installed areas to improve coverage areas within a small vicinity. Things like these picocells would be maybe sporting events where you have a large concentration of people, but they're not moving quickly between cells. You can place a lot of your resources in that one area. So again, that's just the concept and different sizes of these cells. They're not all neat and uniformly have a uniform diameter or radius. Frequency reuse pattern. One of the more common frequency reuse patterns, at least initially, was this 7-cell reuse pattern. Now, what's that distance that you can reuse the frequency? Let's say in cell number 7 here, where can you reuse those same frequencies up here? Well, it turns out to be roughly this formula. If you look at the radius, so that'd be the radius of the cell, which is going to determine the power, be determined by the transmitted power. Then the reuse number, which in our case is 7, that's a very common one, and then some kind of distance. And it really comes out to this formula. The distance is the square root of 3nr. So it's roughly, and again, it's approximately 4.6 times the radius. Whatever that radius is, roughly 4.6, you can reuse that frequency again. Now, as time went on, there's different modulation techniques. There's still reuse patterns, but this changed quite a bit as time went on. But again, this was a very convenient way to draw out the cells. And naturally, you wouldn't always have 1/7 of your frequencies in each one of these. It's going to be determined by geography. It's going to be determined by where the people are, or where the shops are, where it's going to be somewhat fluid also. It's not always just the same amount of 1/7 of each one of these. Another concept is the intra-system handoff, and that occurs when you move from one cell to another cell. So, and on the older systems, on the analog systems, the mobile was not involved at all. It was the system that was actually taking radio measurements and seeing how powerful the signal was. So as you move to this distance here, your signal strength was getting less and less, and this switch would then consult the mobile. This cell tower would consult the mobile switch, and the mobile switch would check its neighbor list and see which cells were neighbor, and it would ask all the neighbors, hey, take a measurement at this frequency, and whichever one had the strongest one, it would then change over to that new cell tower. So the mobile switch would say, okay, now I want you to command the mobile to retune to a frequency. And there'd be a time that this would occur. This would be, maybe 200 milliseconds, a fifth of a second it took to change over from one frequency to another frequency, because you're changing over two frequencies. You're changing over your transmit frequency, and you're changing over your receive frequency. So remember, when you talk on a cellular phone, you have two different channels. You have a channel so you can talk, and then so you can listen. So you two different frequencies that are normally separated by some distance. So this would occur when a call is in progress. The switch would measure the signal strength of the mobile, check the signal strength of all the neighbors, and then assign a new channel, and then command the mobile to retune to that new channel. So again, this is assuming the call is in progress. If your mobile is idle, it just the system notes that you're in a new cell. There's no changeover because you're not using any of the facilities at all. So that's an intra-system handover. Another concept is an inter-system handover, where you're controlled by a cell that's controlled by this switch. And these are called mobile switching centers, MSC. That's just kind of a common term. That's the mobile switch that interprets the digits and sets up the voice paths and acts like just a normal switch would act. So if you're coming here, now this switch doesn't have any of its neighbor lists, so it has to ask another switch here, hey, take a measurement. So this switch would command the cell tower, it takes a measurement and reports that measurement back to this switch. And once you reach that boundary, this switch would then, okay, command the mobile to retune to a new frequency. And this switch would then control that new frequency. Now, again, this only occurs if a call is in progress. If you are not, if your mobile is idle, if you're driving home and you go through two different switches like this, if it's idle and your phone is on the seat next to you in the car, it doesn't do this. It does what's known as an update location. This only occurs when you're engaged in a call. So that's what the first point is here. A call is in progress. The mobile is moving toward a cell that's controlled by a different switch. The serving switch, which is this initial one here, would consult its neighbor and ask it to take a measurement. So I'm going to ask this mobile switch. That's a signaling message. I want you to take a measurement on that mobile. The voice path then gets set up between these two switches. That's a voice path. And then you're assigned a new channel and you command the mobile. This system would command the mobile to retune to a new frequency and the call progresses. So now if the normal call flow was this, let's say this phone here, which is another common term, public switched telephone network, that's the landline. And he called his friend who's on a mobile phone, this friend right here. So as this mobile moves now into here, the signal strength gets less and less and less. So this switch will send a signaling message over to here. It would ask it to take a measurement. The measurement would come back here. This switch would then set up a voice path to here. This switch would then command the mobile to retune to a new frequency. And now you're still talking on the phone. So what happens is the call path now is to here, through that switch, through that voice path, through that switch, out to here, out to the cell tower, and over the air. And that's called an inter-system handoff. And again, you have to assume that there's a call in progress. The mobile is not idle. If the mobile is idle, it's a different procedure. So those are the kind of the four concepts: the size of the cells, the reuse pattern to do a handover from cell to cell and stay within the switch, and then to do a handover from one cell to another cell outside, involving two different telephone switches or two different mobile switches. Yes, question. Is there a question here? Are we okay with that? Yeah, no problem. Like, is there a delay? Yes, but your voice wouldn't detect it. What would be on a slow system like this, a couple hundred milliseconds, you might notice it if you were downloading data. If you're downloading data doesn't like that little abrupt. Now, in newer technologies, they have what's known as a make before break. So you would make with the second one before you break off the other one. Older technologies was a break before make. So you would actually break the frequency on one and then go to the new one. So that voice you would not detect that with voice. Data would not like that. But newer technologies are much better. Okay, yeah, absolutely. Absolutely. So, excuse me, let me get a drink of water here before we continue on. I'll mute myself here while I drink the water. 1 second. Okay, a few basics then. First of all, any mobile network, and it doesn't matter, you've probably heard the term 2G or 3G or 4G or now 5G. These are different, what are known as generations. The generations generally have followed the decades. The 1980s was the first generation, the 1990s was the second. We'll talk a lot more about generations in the future. The early 2000s was the third generation. The fourth generation was in the teens, and now into the 20s is the fifth generation. And again, we'll look at this a lot more. But one thing that's common on any generation is any mobile network, there's always three different unique pieces. There are three parts to a mobile network. First is the user equipment. Now, in the old days, that was strictly just a mobile phone. Today, it can be a whole variety of different things. It could be an IoT device. It can be a sensor out there that's measuring wind or measuring pressure in a pipe or something like that. It can be a lot of different things today, but the user equipment is one end. That's one piece of a mobile network. The other piece of the mobile network is called the RAN, or the radio access network. And the radio access network, again, changes over time. Early generations, this was an analog signal. Today, it's a digital signal. And this cell tower, it's called the RAN. The RAN has to connect into the last piece. And the last piece is called the core network. And the core network is made up of different pieces, different devices. They're called different things as the different generations are come along, but you need some kind of central switch. So initially, this was called the MSC, or the Mobile Switching Center, and that's a telephone switch. That's the device that when you dial the digits, it interprets those digits. It has to know, what do I do with those digits? Do I set up a voice path to a major metropolitan area? Do I ring the phone locally? So it connects to all the other switches out there in the world, ultimately in the world, not directly. You go through other switches. But a mobile switch is a device that's going to interpret your digits and act like a normal telephone switch. There's also various devices. There's also various registers. There's also various databases. One of the registers or databases is called the visitor register, and that's keeping track of all the mobiles that are in that switch. So, and it might be roamers from outside the network. If I get on a plane and fly over to Accra and I power my mobile phone on, I'm a visitor. And a record of what I have in my home network will be copied and sent over to the visited system here. Because the visited system, once a roaming agreement is signed between two companies, that means that I can roam in your network. It also means you can roam in Verizon's network. And the two of them need to exchange information. So if I get on a plane and then my plane lands and I power my mobile phone on, a copy of my profile. What's my profile? Oh, it's the services I have. It might be if I have any restrictions. Am I restricted from mobile originated calls, mobile terminated calls, any short messages? Maybe I have supplementary services. Maybe I have call forwarding or call waiting. So the visited system would need to know that. So it'll ask the home system for a copy, and a copy of my information will come over. That'll be kept now in what's known as the visitor register. There's also a home register. Now that's the central repository for all of this network's customers. So it knows several things about you. It knows all of your services. So if you go to another network and you power your mobile phone on, let's say you get on a plane and you fly to another country or to another city somewhere and you power your mobile phone on, that system where you're at will ask your home system for a copy of your profile. So it's called the home register. It's where the subscriber's profile and the subscription information is kept. It has different names with different generations. Some later generations call it the home subscriber server, the home location register. It really means the same thing. One of the key things about the home register, and we'll mention this many, many times, is it knows where you are at. So any service Any service that needs to find you will always consult your home location register. So if I pick up the phone and I call one of you, that call will be routed to your home network, and your home network will ask your home location register, where are you at? Are you currently registered in Accra? Are you currently registered in another city or another network somewhere? So the home location register knows where you're at. Any service that needs to find you will always consult the home system, the home register first. Short message service. If I tap out a short message to one of you, it's got to find you. It's got to find you somewhere in the world. So it'll consult your own home location register, your database first. And there's other databases in the home system, things like authentication. There's equipment registers, so it keeps track of their hardware equipment. There's message centers. When you tap out a short message for one of your friends, it goes to a message center. That message center holds that message and goes to find the recipient. Somewhere in the world is the recipient. So these are all things that just make up what's known as the core network, the mobile switching center, the visitor register, or some device that's keeping track of any visitor in its system. The home register, which knows where all of its subscribers are at, and it's a central database, central repository for all of your services. And then other types of databases that we'll look at again later on also. So those are the basic parts. All networks have three parts. You have your user equipment, you have your RAN, radio access network, and you have your core network. And again, it changes. The piece parts change over the generations, but each generation has those three pieces or those three parts. So what is needed? You have a new mobile registration. And let's just go through the steps. You power your mobile phone on. Maybe you come into an area, maybe it's the first time in the day, you power your mobile phone on. Inside of your mobile phone is a card. It's a small little thing called the SIM, S-I-M. And that SIM card, subscriber identity module, contains your identity. Now, your identity, you're known by your friends by your telephone number. Someone wants to call you, they want to talk to you, they dial your telephone number. But inside a mobile network, the telephone number is not that useful for it. It has another identifier. That identifier is called your IMSI, your IMSI, International Mobile Subscriber Identity. That defines you. You are unique in the entire world. You're unique by that IMSI. And that IMSI points to who your provider is, whoever your mobile provider is. So when you turn your mobile phone on, your IMSI needs to come out into the air. And it's going to be picked up by a cell tower. And that cell tower, which is part of the RAN, the radio access network, is going to be connected to the mobile switch. And the mobile switch, the first thing it does is it wants to know, hey, do you know who this is? So it asks its visitor register, do you know who this is? Is this if you're already known in the system, it just says, yeah, I know who that is. I'll just make note of the time of day. I'll make note of the signal strength, and that's it. We're good to go. If it doesn't know about you, let's say I fly to Accra and I power my mobile phone on, out comes my identity. The switch in Accra looks at its visitor register and says, hey, do you know who this is? And what is it? This visitor says, I don't have a clue who this is. I don't know who this is. But based on that identity, based on that international mobile subscriber identity, it points to a home system somewhere in the world. So that visitor register will then find the home register of whoever that subscriber is. And it'll ask the home register, hey, I need some subscription information. Now that home register might be halfway around the world. It might be, if you're in your home system, it just asks its own home register. And the home register makes a copy of your profile, your subscription profile, and says, here's a copy of it. Keep it here as long as that subscriber is here. So now you're known in the visited system. Once you do that, you're known in the visited system, and now you can use your mobile phone. So the visited system asks the home system, the visitor location register asks the home location register, for your profile, your subscription information. Would you have any restrictions? Do you have any services? Is there anything that you can and can't do? In other words, your entire profile is sent over. Think of it as making a copy of that and sending it to the visited system. So it'll give it the subscription information that it wants, and now the visited register has that. Once that happens, the serving register keeps a copy of the subscriber's profile as long as you're in the system. How about the user? The user can now move around. The user can place calls, it can receive calls, it can place and receive text messages, it can modify other services, supplementary services, things like call forwarding, call waiting, three-way calling, all of those what are known as supplementary services. Now, the other key thing is the home register knows a couple things. The identity of the serving switch where you're at is known in the home system. And this is a very key thing. Any service that needs to know where you are will always consult the home location register. What services need to find you? Short message services. A text message has to find you. If I send you a text message, the system has no idea where you're at. It has to go to your home switch that I give your profile to. If I pick up the phone and call you, it'll have to go to your home system first, your home register first. Where did you send that information to for the visited system? So that's a very, very key thing. Now that you're known, you can use your mobile phone, you can wander around, you can receive calls, place calls, and so on. Questions? Anyone understand how that whole concept works? Mm-hmm. In other words, is there other information on the SIM card? Yes, there's a lot of other information on the SIM card. There's other information on here. This is you. This SIM card, which has different names, is called the U SIM and different generations, but it contains more than just your identity. But that's one of the key things it contains. And that secret number, this number right here, this MC, you don't know what that is. It's stored here on the SIM card, and it's stored over here in the home register. No one else knows it. So you can't, there's no, you can't look in your profile, you can't look in your settings, you can't look at anything and say, hey, what is my MC, my international mobile subscriber identity? Because that MC makes you absolutely unique in the world. There's no one else that has that identity except you. And it's always made up of, it's the numbers that makes up is the mobile country, what's known as the mobile country code and the mobile network code. So for me, it would be the mobile country code in the United States, the mobile network code, Verizon. And then there's identities beyond that. So it's a unique number that points to your home system. Yeah, but there is a lot, and we'll look at there's other information on the SIM card, and we'll certainly look at that. Absolutely. Yep, absolutely. Hmm. Hmm. Yeah, there's other parts to this. It's more than just a cell tower. There's what are known as base transceivers. There's base station controllers, but overall, that's called what's known as the RAN or the radio access network. And again, with each generation, it performs different functions. But the key function is this: it has really a couple functions. One is it's the radio interface. It understands the radio interface and it's connected into the core network. So it's the interface between the core network and the user. It's that radio tower. Okay. Mm-hmm.
So I wanted to ask, is there any situation whereby the mobile switching center might not get information from maybe the home register or the visitors register?
Is there the question, from what I understand, is there any time when the home system would not communicate with the visited system? Is that what you're asking?
Yes, please.
Yeah. So the question is, let's say you power your mobile phone on, and it comes here, and this visited system cannot communicate with the home system, wherever that might be. The phone won't work. It has to. It's not. It can't work. It has to do what's known, and this process is called an update location, and it uses different signaling methods to do there. Again, depending on the generation, but in order for you to use that mobile phone, you have to communicate with the home system. The only exception is emergency calls. And that I don't know if that's universal throughout the world, but like in the United States, you can always power on any mobile phone, and you can always use it to dial 911, which is the emergency number. So if you have a national emergency number, generally you don't need to be registered onto the system to use that. But in order to use the phone, to receive calls, to use text messages, to place a call, you have to be registered. So it has to communicate with the home system.
Okay.
Okay,
Thank you.
absolutely.
Thank you. So Raymond, you have a question. You can go on.
Yes, my question is related to the security. Since the home register is able to get the information from the previous location of the person, I want to know how secure this information can be.
In other words, the question is, when the visitor register communicates with the home system, how secure is that?
Yes,
It's not. I know that's a short answer, but if this visitor register needs, let's say, and let's use an example of me flying to Accra, because now the visitor register in Accra has to communicate with a home system in the United States.
yes,
So how secure is that? It is not. And most of the communication from here to here goes over IP. So it's an IP type of protocol, and that's a private network, but it is IP based. And on top of that, the actual messages themselves are not they're not encrypted at all. It's just kind of clear text messages, and that those messages carry a lot of information about your location, about your status, about your services, and your identity. So it carries a lot of information in there, and they are not, as a protocol, the actual communication protocol is not secured at all. Therefore, there's a need for things like firewalls. There's a need to build in security, to put security, since the protocol itself. Part of that is because the protocols used in these systems were legacy protocols. By that, I mean they were protocols written back in the 1980s, 1990s, when security was not a concern. Today, security, there's more IP, there's more providers out there, there's more interconnections out there. Security is a very, very large issue. So, but the protocol itself is not. It's not like it's a VPN or anything. So, yeah, that's a very, very good question. Very, very, very timely question. Hopefully we'll get into some of that in the next few months. We'll get into some of the security aspects, because there's different protocols. SS7, you might have heard of that. Diameter, you might have heard of that. SIP, you might have heard of that. The different protocols with different varying degrees of security. But that's a very, very good question. All questions are. Yeah, so here's what we're going to pick up now. This is the A cohort. We'll pick this up next Wednesday because I'm not going to be here Friday. I've got a funeral that I have to attend in the morning, so I'll be unable to attend. So let's pick this up next Wednesday, and so you can start your class a half hour earlier on Friday than Raymond or Raphael. I mean. And this is where we'll pick it up. We'll talk. I want to talk about the actual industry itself, the associations, the bodies, the operators, and just financial clearinghouses, just something about the network, the mobile network industry. And we'll pick that up 1 week from today. Again, I will not be here on Friday, so I apologize for that. Okay. Thank you, everyone, very much. Enjoy the rest of your day. Enjoy the rest of your session now this evening, and all the best to you. If you have any questions, Steve at cellulosys.com, and you can always go through Raphael also. So thank you. Thank you for your attention. Bye.
All right, thank you.
Thank you.